Good evening. I hope you enjoyed your dinner. Because our mission is to reduce man-made threats to our existence, that is, to unleash the good and constrain the risk, I cannot think of a better person to introduce to you tonight as our keynote speaker. Eric Horvitz is a member of the Bulletin's Board of Sponsor and is a technical fellow at Microsoft and director of Microsoft Research Labs. He is a globally recognized leader in artificial intelligence and machine learning, with a PhD in computer science and an MD from Stanford University. His work has focused on machine learning, its enormous potential, as well as its real risks. His many achievements include serving as the president of the Association for the Advancement of Artificial Intelligence, chair of the American Academy of Arts and Sciences section on Information Computing and Communication, and on DARPA's Information Science and Technology Study Group. Among his many achievements, he is also a board member and founder of the Partnership for AI, which was established to study and formulate best practices on AI technologies to advance the public's understanding of AI and to serve as an open platform for discussion and engagement about AI and its influences on people and society. I imagine that our founders would have jumped to be part of this partnership, as it is a very Bulletin approach to thinking about new and powerful technologies. When I first asked Eric to sit on the board of sponsors, he wasn't so sure about it. Eric was concerned that AI and nuclear risk and climate change were disparate issues. But our founders worked at the intersection of huge, complex issues, and I asked him to think about the contributions he could make to our thinking about the future of technology, AI in particular, and its effects on humanity, and the seam between AI and nuclear security, among other issues. I was so delighted when he accepted our invitation, perhaps just to get me to stop calling him. But I think we're all in for a treat tonight, and I hope after his forthcoming remarks, you will agree that I was right to persist. So without further ado, I'm delighted to introduce tonight's keynote speaker, Eric Horvitz.
Well, thank you very much. I've been absolutely enthralled with the prospect of knowing more about how minds work since I first listened to the Morse code signals coming out of a rat's brain that I had just stuck with a microelectrode in a neurobiology lab as a biophysics undergraduate. Very, very passionate about the prospect of understanding computational mechanisms underlying thought and intelligent behavior. I couldn't think of a more important and interesting thing and a harder thing to do as I moved on to graduate school at Stanford. The founders of the field of AI in 1955 wrote a proposal and used the phrase artificial intelligence for the first time. And in that proposal, they said that their goal was to find how to make machines solve the kinds of problems now reserved for humans. Interesting definition of a field. They actually, in a very modern proposal, I often joke that if it was submitted to DARPA or the NSF today, it would probably get funded, or at least a high score. They called out key pillars of work in perception, learning, reasoning, and especially natural language, which has a special role in human intelligence, and then laid out a course for how this might go over time. And I have to say that even though we typically in the public domain hear about big wins like the Watson Jeopardy system or AlphaGo or a self-driving car, there has been a continual stream of advances coming out of the field over the years, on and off, even if progress, even to this day, is dramatically slow, at least when you go back and listen and understand what was on the minds of the founders in the late 50s. Some people thought that by the 70s, all important work required to be done by humans would be being done by machines by then. So you can imagine, even with our excitement now, how disappointed these folks would be to be transported to 2020. And, well, where are the robots? What's going on? And hasn't happened yet. But there's been a great set of contributions in healthcare, transportation, systems, computing systems, and in many, many areas of human discourse. But about 15 years ago, there was a palpable inflection in AI capabilities, largely due to an inflection we've all experienced in the sheer amount of computation available, even in our pockets, the amount of memory available. If people remember back in the 80s to go out and buy a 40 megabyte hard drive, that cost me about half of my graduate fellowship. And when it crashed, I lost everything I'd ever done, as I recall. Also, we take for granted now the amazing amounts of data spinning across devices and across the internet, typically captured in a low-cost way by almost infinitely inexpensive memory that we don't think much about, terabytes of data. The web and the behavioral data available now is just really impressive. This data was not available even in the mid to late 90s. And then, fueled by the data and the computation and the memory availability, it's really been a frame to do even more work on learning and reasoning algorithms that could sort of ingest and make sense of that, and to build systems and artifacts based on the core resources. So going back in the history for myself here, my graduate work was pursuing what I called foundational principles of intelligence that might explain human minds as well someday. And this led me to thinking deeply about principles of rationality under bounded resources and bounded information. We're all limited as humans and other animals, or other vertebrates, for example, immersed in a very complex universe. How is it that we make sense of it and get through that universe with such limited resources and limited knowledge when it comes to what we could and might know, typically, of course, under uncertainty and inescapable incompleteness in the representations we have of the world? This got me very excited because I thought there were some sparks of what intelligence might be in that set of questions. And this led to a set of technical challenges. Typically can be framed as, I take a small prototype in the laboratory and I throw it into the open world. How will it do? Can I give it the abilities to understand its own limitations in its knowledge? Can I give it the abilities to understand what's dangerous versus not? So exactly 11 years ago in Chicago, at the main conference of the main scientific society, International Society for Artificial Intelligence, called the Association for the Advancement of AI, I happened to be president, and I was asked to give a presidential lecture. And here was my lecture, calling upon the community. The first slide, see the beautiful Chicago skyline there, calling upon the community to think deeply about the technologies we would need, given the inflection we were at, to put these technologies safely into the open world. Called it Open World Artificial Intelligence. In the second half of my lecture, I said it's not all about technology. There's also how these technologies influence people and society. Will they be safe? Will they represent our values and be ethical in their behaviors, even when they're semi-automated or working with people? What about legal issues, privacy of the data they're using? Will they be understandable, transparent? What would be new policy challenges? And I claimed to the audience, and I charged the audience that I would create a presidential panel on long-term AI futures, saying that even subtle systems that we're building now, if they happen to have even subtle biases, given the internet and the spread of devices, they could make major waves in society. So we called together the best people I knew to think through these questions, and these were the best people I knew who happened to be fabulous technologists and scientists, but also who I knew over the years were the kind of folks in the AI community who would be interested in going deep on the social, societal influences and safety issues. And we met for 6 months offline with 3 separate groups and came together in February of 2009 at Asilomar to discuss our results over 3 days. The groups were broken down into short-term disruptions, long-term futures, and legal and ethical issues. 3 separate teams worked away and did reports. I specifically asked the long-term futures people to think deeply about fears of runaway AI that may take charge of itself and not take orders from people. Of course, there's an ongoing science fiction thread about that, but the questions and concerns are actually real. And I had folks actually going deep and give a set of beautiful reports on how we might build systems such that the representations and reasoning methods would always be verifiably answerable to human beings and would operate within constraints. We also thought deeply about intrinsic problems in AI systems that you just can't escape, part of the representation and reasoning. Inadvertent effects, you just didn't think deeply enough about how the system would be used in the world. And malevolent AI. And I remember at the Asilomar meeting was the first time I heard the phrase criminal AI used by state and non-state actors and going through possible uses of this technology and how it might be leveraged in the future. Now, an interesting article came out above the fold, front page of the New York Times a couple months later, and you can imagine that this article focused on loss of human control of computer-based intelligence. This is a very exciting issue, and covered several of the other topics. And it generated quite a stir. The phones lit up at the organization. Reporters wanted to know. We've heard from science fiction writers, but this was a first meeting of scientists. Are they saying this too? Should we be worried? That was the question reporters were asking us at the time. So that was a topic that was discussed and became a hot topic, and it's still a continuing one. But of course, more shorter-term issues were focused on by the teams looking at short-term disruptions, including failures and blind spots and biases in AI systems, threats to human rights for particular uses, risk of injury and death, how do we understand these systems, intelligibility and explanation, influences on democracy and discourse, adversarial attacks on these systems, particularly at times with AI itself, and related issues. Now, I happened to ask the 2 initial speakers at the meeting at Asilomar, give a talk on something that you think will surprise us. And remarkably, they gave related talks that remarkably predicted what would happen the next summer. This was February, and in August at Microsoft Research, where we had Jeff Hinton and interns with us, we discovered that perceptron-based methods, we now call them deep neural nets, that had largely been unchanged for a decade. They didn't work as well as some other machine learning methods, learning prediction to do pattern recognition from data or predictions. They didn't run as well, so they had lost favor. But we discovered that they were all this time simply famished for data. And now we had that data. In fact, we fed the system switchboard data, which is a speech data set, a workload created by an unnamed government agency of people talking on low bandwidth phone lines, having conversations. Now, lest you be concerned, these were paid subjects. They said, just call up and have some phone calls. But it was a challenging data set that had a word error recognition rate for at least 10 years. It had been a plateau, unchanged, and we saw a dip. And since then, that dip has gone towards superhuman levels of understanding. Same methods, essentially, with some modifications were applied beyond speech recognition to perceptual tasks like object recognition, language, and even robotics. And to date, for specific workloads that are pretty broad-minded, in fact, this object recognition workload, we have systems that work better than people at those tasks using this methodology. And you can imagine companies like Microsoft and competitors have all sorts of applications we've been coming up with. Cloud services you can call and program to look at gender recognition, age recognition, all sorts of text comprehension tasks of various kinds. The radiologists have gotten excited about the idea of sort of automatic radiological segmentation, for example. You can imagine many, many beneficial applications are possible moving forward. And there are whole new paradigms, just to give you a sense for the research. One paradigm right now is given that we're often in a world of data scarcity, training models inside simulated worlds, building high-fidelity physics simulations, and, for example, flying drones in those worlds. And since we know what the world is all about, we can put, and we know our sensors, we can put realistic models of sensors into that world, collect data, and build models, for example, like this one here, that can be trained offline and then be deployed, for example, to inspect high voltage wires in a remote province trained in simulation. Another approach is, hey, let's combine all these different methods we have, vision, speech, language abilities, dialogue control. Let's build a system that might provide human-like services in some narrow domain, like by my door, for example. If you visit me at Microsoft Research, you can come talk to my assistant, who knows more by calling 17 years of data about the meetings on my calendar that I won't attend than my regular assistant who's newer on the job. Mm-hmm. She actually lets people pencil things in and so on quietly, like with a little hush. He's not going to that meeting. Interestingly and concerningly, with some concern, we're seeing higher stakes applications now in transportation, in healthcare, and in military applications of these technologies, and a certain kind of push and exuberance in applying these methods in these high stakes areas. And of course, I shouldn't say of course, but it would have surprised me back in 2009 when we had that Asilomar study to look at headlines like this coming out a few years later on the rough edges of where AI systems, even simple ones, are meeting society and creating concerning effects. For example, biases in classification, safety issues with cars, issues around persuasion, manipulation that might influence democratic processes. I and others have written reflections about where things are going with AI. We've seen salient stories and interesting analyses of machine bias, for example, in criminal justice. Predictive models being used. Will a person charged with a crime come back to their court date or not? Recidivism, risk scores, and so on, where we show these scores or these systems are actually amplifying existing biases because the data is becoming a vicious cycle of sorts. Same thing for healthcare. A recently fabulous article in Science magazine 2 weeks ago showed some challenges with medical systems based on some indigenous biases in the actual data sets being used, hidden and cloaked before this analysis was done. So 5 or 6 years ago, I thought to myself, where AI is right now is kind of like the Wright brothers with the simple kite-like plane with the canvas flapping on the Kitty Hawk beach. But you look at this picture. This is the first captured longish flight, whatever it was, a minute, and who knows the exact time, minute, 20 seconds, or whatever it was. Just 50 summers later, have the 707, and along with that, it drags the world into a whole new regime of where you have certain procedures and processes in place, how flight works, how you travel, how you advertise travel. What does the tower talk to the pilot about? What's the language they use? And I thought to myself, boy, it's been slow. It's been a slow burn, this AI, but we see a couple different inflection points coming, and it could go pretty quickly. So one thing that I did was I worked with John Hennessy, the president of Stanford University. My wife and I worked to create an endowment we called the 100-Year Study on AI at Stanford, and we list in a memo called this reflection framing memo. We listed 18 topics of concern that we thought should be studied over time proactively to get ahead of the curve, to think deeply about the frontier, and to come up with policies and to be ready and active given the possible changes over time. The first report came out in 2030, and the idea is to do a report every 5 years I'm looking forward to the report coming out next year, the second report of the AI 100. It's all about proactive reflection, staying ahead of the game and thinking through possible disruptions coming with AI. The 100-year study also spawned the Artificial Intelligence Index, which is an annual report. The next one is due out this winter. This is a report that captures, through various benchmarks, including human intelligence as a benchmark, different capabilities over time and how well we're doing over time along many dimensions of what you'd call intelligence. Another thing that I've been involved with is this idea of red team, blue team. People talk about all sorts of AI concerns and AI nightmares of various kinds. And 2 years ago, I co-organized a meeting where we actually wrote out and invited in a call for adverse outcomes, widely distributed call, asking people to just not just be worried and sit on their hands with worry. Write down explicitly this is AI experts, what is your worst artificial intelligence adverse outcome, your AI nightmare? Write it down in a schema. Is it long-term, short-term? Will it be acute? Will it be chronic, hard to escape? Describe the trajectory of how we got to this place and how it could be avoided or disrupted. And we basically filtered through a whole bunch of these proposals. And for this meeting, we picked 6 really interesting, we thought, compelling proposals. And then we called a meeting with a red team and a blue team for every single adverse AI situation or proposal. What you see here right now is Kathleen Fisher, who's chairman of CS at Tufts University. She's a fabulous cybersecurity expert. And this particular image here was of the battling red team and blue team on how to counter an AI cyber warrior. This particular one went poorly for the blue team, and it led to a National Academy study that will be published shortly on AI issues with cybersecurity. We had very distinguished people. We had winners of the DARPA Cybersecurity Grand Challenge on this panel, the leaders of that challenge, as well as senior verification people and a senior person from the ONDI, the Defense Intelligence Office, who walked away looking at me with knitted eyebrows saying, we have to study this more deeply, I'll see you later. By the way, just to get Doomsday up into this talk, one of the news articles called this meeting, AI scientists gather to plot doomsday scenarios and solutions. And there were solutions as well. So directions moving forward in our team and other teams that have related kind of pillars of work are working really hard to address the brittleness of narrow AI solutions, mastering human-AI collaboration. How do you build systems and technologies that really support humans and machines working together in a fluid manner where machines augment human intelligence? People are in charge, but they get smarter with the machines. Machines that know human cognition really well and know human biases and blind spots that can help fill them. And addressing challenges of influences on AI and people in society. Let me just say a few more things about this last topic here. It's kind of the focus today. We have a lot to do as a society, whether it be government agencies and our legal system and laws, private sector, academia, civil society, to think through, as we see these technologies arise, of automation coming into places where in the past people have been in charge. What are the responsibilities? What kind of regulations do we need? We're going to need regulations around safety in different domains, whether they're domain-specific or general, around issues with human rights, civil rights, fairness, and so on, understandability, transparency, controllability, and privacy. 3 years ago, at Microsoft, we started a conversation, Satya Nadella, I, and a few other people, asking the question, what are Microsoft's principles when it comes to our AI principles, we called them. And that's an example of what we think other organizations are going through. And we chose 6 principles here: fairness, reliability and safety, privacy and security, inclusiveness, transparency, and accountability. And shortly thereafter, we created an advisory board with representation across the whole company called the Ether Board. It stands for AI Ethics in Engineering and Research. And set up 7 working groups, each co-chaired by experts, some from Microsoft Research and other areas of the company, and each maybe about 5 to 15, 20 people that are kind of the furnace of innovation. And this whole operation works in several ways, but in one way, it actually helps advise the senior leadership team on policies around sensitive issues when it comes to AI products and services. And it already had quite a significant effect on gating and guiding Microsoft technologies and how it works with customers in different parts of the world when it comes to these technologies. The groups also work on technical challenges. So the Bias and Fairness Working Group, for example, was looking at Microsoft's facial recognition service, which was supplied to developers and others who access that service, recognizing that there were problems where it was failing on gender recognition for darker-skinned women, and really worked to fix it by generating new kinds of tools that let us probe the system more deeply and understand it better as to where the failures were. The Sensitive Uses Committee has become a real interesting working group that actually receives challenging problems and makes precedent by making advice to the SLT, the leadership team, that comes back down again as a yes-no based on the recommendations, and then that becomes precedent for the company, and if something falls outside of precedent, back to the Sensitive Uses Committee. But for example, even defining what's a sensitive use of AI to educate our folks, denial of consequential services, risk to human rights, risk of harm. This has been very valuable to us. It takes sitting with our human rights key leads and thinking through the Universal Declaration, the guiding principles on business and human rights from the UN, and Microsoft's own human rights policy. As I say, the canary in the coal mine for Microsoft has been facial recognition, which is a new, powerful technology. You can point at a stadium of people and do identity across thousands of people in some situations. We've already heard stories about authoritarian regimes doing this kind of thing. Microsoft has called publicly for government regulation of facial recognition, even going so far as to lay out the wording of legislation and working in Washington and both Washingtons, federal, state, as well as California and other states, on proposed legislation and principles for how you deploy this technology in private and public situations for government uses. I want to end by talking about AI and military, given the security focus of part of the mission of the Bulletin. There was a really interesting directive called Department of Defense Directive 3000.09 that many of you might be familiar with in the Obama DOD in 2012. Part of it said here, autonomous and semi-autonomous weapon systems shall be designed to allow commanders and operators to exercise appropriate levels of human judgment over the use of force. This was a statement made given the interest per the rising the rise of possibility of having more kind of semi-autonomous and more kind of autonomy using AI in our weapon systems and surveillance systems and so on. This is asking for human judgment, meaningful human judgment. Of course, even on top of that, reports and analyses have come out about the dangers of autonomy of various kinds and raising the level of autonomy with AI and weapon systems. And just this week, I came into this meeting from Washington, D.C., and I was talking to others that were at this meeting. I happen to be a congressionally appointed commissioner on the National Security Commission on AI, a congressional committee that was appointed to study AI issues with national security. And we just filed our interim report on Tuesday of this week and rolled it out in a large meeting that involved many senior folks, Secretary of Defense, head of DARPA, head of NSF, and we had a bunch of Congress people there. We had Chuck Schumer come. That's where he made a statement about the $100 billion over 5 years he was going to put into AI. He was going to try at least. meeting with the OSTP in the executive office and so on. This report is interesting in a number of ways in that it cites ethics as a key unifying principle across all the goals of national security. It also calls out another piece of work that was published just about a week and a half ago from another org in DoD called the Defense Innovation Board that put together an AI principles project all around ethics, calling out and summarizing the need for responsibility, systems to be equitable, traceable, reliable, and governable. I want to end by saying that these statements are they're powerful and interesting, but they'll be hard to implement. And this is one of my concerns. So I'd like to publicly talk now and just end with 10 challenges that I think for the first time I'll mention publicly for AI and military applications. What you see here is a picture of several of us. These are several presidents of AAAI with other experts. We visited the Obama White House in the last year of the Obama presidency. I co-authored a letter to President Obama with a couple of colleagues, calling out, it wasn't exactly like the letter back in the 1930s and early 40s, but we were calling out the concern with rising interest in autonomous technologies in weapon systems and wanted to speak to the president and to folks in the DoD. And the team, the OSTP and team arranged, and the chief of staff arranged a beautiful meeting with a whole array of very serious DoD officials from different branches of the DoD. It was a great meeting. I'm sitting there next to Tom Mitchell, another AAAI president of the past, Stuart Russell, Bart Selman, Mike Wellman. All folks, many of these folks had been involved in the Asilomar study and were very active back in 2009. It was a great conversation, and I shared several of my concerns, several of which are on this list here. Let me just read this list to you now, and we'll end the meeting in just maybe. Are we taking questions, Rachel? Okay, no questions. Okay. 10 challenges that we need to worry about / caveats with AI applications in military systems. Number 1, errors. Designs and operations must take into consideration inescapable errors derived from AI systems. These are typically false positives and false negatives. You can't get rid of them. Oversight. Pressures to remove people from key oversight and decision-making responsibilities must be met with wisdom and caution. 3, time. Efforts and innovations should be aimed at protecting sufficient windows of time for human reflection, input, and intervention. And this is despite pressures against that, the narrowing of time for meaningful human involvement in these systems. 4, testing. Designs and processes must take into consideration the difficulties and impossibilities of fully testing AI capabilities in realistic operational settings. It's not possible. Complex interactions. The potential rise of unexpected behaviors in the complexities of interactions among AI systems themselves, within and across adversarial lines, must be considered and addressed. Adversarial attacks. We must prepare for and expect adversarial attacks on AI components in our systems. Many will be driven by AI itself or themselves. Deception. We need to be vigilant and ready for new forms of AI-powered persuasion and deception, targeting military and civilian leadership. And the last few here, shared goals, a very important one we don't think about enough. We have to collaborate with potential adversaries and seek treaties to minimize potential instabilities around uses of AI technologies, and we have to work to jointly extend time horizons, to not have a race to no time, but to jointly extend time horizons to permit meaningful human oversight on all sides. Human-AI interaction. We have to invest in human-AI interaction technologies, including capabilities that relay confidences about inferences, how confident is the system, that provide insights and explanations, and that support decisions under time pressure and stress. And finally, concern, ethics and the future of warfare. We must stay vigilant about the potential need to assert new kinds of ethical principles and norms around applications of AI that change the very nature of war, such as personalized warfare that targets individuals or groups based on identity or racial features. Let me just end with a word from Herb Simon, one of those folks who wrote that co-drafted that initial AI proposal, a personal friend, mentor, and hero of mine. His comment here is that you heard lots of interesting challenges and questions and caveats. He said, look, professional responsibility is not to discover the laws of the universe, but to act responsibly in the world by transforming existing situations into more preferred ones. And I'll stop there.